The cylinder structure is really, really important from a standpoint of how multiple platters work. Your data is written on the top of a platter and then the bottom of a platter and so on down through the platters. So this makes it incredibly difficult to take more than one platter and move it to another drive to alleviate your problem. So if you had two drives and they were identical and you just wanted to pull out your platters, in this case, if you have one, you can move it. If you have more than one, you'll have a problem because the cylinder will not align itself. If the cylinder turns at all, even a minute amount, you will never get those disks to line up again and read your data from it because the bit that's on top won't match the bit that's on the next platter to work in parallel to actually get that content off. But one of the really important things here is the beginning of a partition structure. Standard formatting tools will basically make a partition structure start on cylinder boundaries. So the point is that if you know where the cylinder is that your partition structure started, you can go straight there and not have to go through every single bit on the drive to try to figure out where your beginning of your partition is. And there are certain tools like ByteBack that will actually go directly to all of the sector boundaries, the cylinder boundaries, and find out if that's where your partition structure starts. One of the important things here is that if you had to scan every byte on the hard drive, you have a really good chance that it's going to fail when it hits a bad block. So it's not going to continue on. But if you could just skip all the other content and just look for that partition, you might be able to get your MFT and actually do a recovery of just the file that you want because the MFT will tell you where your file is. So depending on how damaged the MFT is itself. Now the MR head, that's a magnetoresistive head. That is the head that you can think of as the head that we used on hard drives in the 90s. So if you remember the days when your hard drives were really reliable, it was because of this head. And most of the changes that have happened have been on the next head, which is the GMR head, and that has mostly occurred since late 1999 and up until about last year where they made some other changes. But this head was very stable, it was very simple, and you're really looking at hard drives that were really less than 20 gigs, but more likely 10 gigs and less. 16 gig hard drives started switching to the GMR head. It was designed by IBM, and they started putting them in SCSI drives in 99. So this head is a fairly simple head. It basically has two pieces that know when something's changing. And so it's a magnetic head that can read the change that's underneath it. So assuming using my artistic license here that looks like a bit, and I would like to explain to you that most people seem to think that a hard drive has zeros and ones written on it. And it does not have zeros and ones. It is encoded, and it's similar to an audio stream. So what happens is the electronics, as the content passes through them, they actually even have a preamp on the arm, and they encode the signal and put the signal on the drive, and then they decode it when it comes back off. And it looks a lot more like a sound wave when you're looking at it. You have your valleys and your peaks and ups and downs, and it tries to determine what that is. But it's encoded. It's not a 0 and a 1. So again, artistic license here. The MR head would detect, as the bit passed underneath it, that there was a change in magnetism, and that would cause a bit to flip, basically, so that you could actually read that there was a high and a low, and then you have a bit. But the GMR head is quite a bit different. This is actually an act of physics here, and I'm not a physicist, so I'm probably going to completely destroy what's going on here, but the whole point of the GMR head is that they figured out that if you took two magnets and you put a soft piece of material between them, that the two magnets would align themselves with each other. And then at the end there's a ferrite bead to kind of help shield content from getting destroyed on its way. But the two magnets, because they are aligned and there is this soft piece of material between them, as the bit passes under it, it can detect that the bit is coming. But it doesn't actually detect that the bit was there until it's already past it. So it's gone past the heads, and it causes the electrons to bounce around in the second component here that causes something called a spin valve to change. And the spin valve is how they detect that a change has occurred as it passed underneath my head, and now I know that I have some change that is a bit. And the new heads are actually even more significant than that. Some of the new stuff that's coming out from Fujitsu and things are 7-layer heads. So this complexity is part of our problem as to why we start seeing these degenerating drives. We've got an increase in density as time has occurred, and we've got a more complex head that's moving closer and closer to the platter and reading more and more dense material. So this is what most drives look like that are manufactured today. So as of the middle of last year, almost every manufacturer has switched to a perpendicular recording. Last year I gave, in my speech, I talked more about longitudinal and the other things that happened previous to last year. So if you go watch that speech, you can actually get into that stuff and see what that looks like. But the perpendicular recording mechanism is a way that they figured out to write a bit up and down instead of long ways across the platter. So they're basically squeezing a 2-to-1 ratio in here. So when you get a 200 gig hard drive, in some cases it's 100 gig that now is recorded with perpendicular, and that makes it a 200 gig drive in your laptop. But so you have a lot higher density again, and we're really talking about a short span here. We don't really know what the effect is over time. I mean, it could be next year you start getting a whole pile of these hard drives in for recovery because perpendicular is failing, or we don't really know what our issues are going to be at the moment. So far it seems to be fairly stable. I'm having about the same problems with perpendicular that we have with longitudinal, except that our density has increased, so it makes our recovery a lot harder. But one thing that has changed is that for one thing, primarily IBM used glass platters before last year, but most manufacturers now have all had to switch to a glass platter because the previous aluminum that they were using in their platter would affect how you can read and write to perpendicular. So most of the drives now are going to a ceramic glass platter. And that's one of the things where when you've actually got a scratch on your platter, it's pretty easy to see. In some cases it digs a ditch, and you can see through the platter itself, especially if it's happened on both sides and you actually had some sort of a catastrophe where you dropped your laptop off the stairs. It'll dig a big ditch on both sides, and if you pull the platter out, you'll be able to see it clearly. If you have one of those, it's probably just going to destroy your heads if you put new heads on it and tried to do something to repair it. So the substrate here is the main thing that has changed, and it will probably affect quite a bit of the drives that we have coming up. Now, if you're doing data recoveries, most of the tools, any of them that are kind of the high-end tools and not just like I'm going to click one button, scan my hard drive, and try to do a recovery, most of the tools have decided to come up with a mediocre kind of technology to talk to you and tell you what kind of errors are happening on your platter. So most of that will look like this top line up there. The top line, basically, I'm not going to tell you what every single thing means and how to go through it, but as you start doing data recoveries and you start trying to do a scan to try to find out what's with your drive, you're going to start seeing terminology like this. And there are free programs that are high-end programs that can do this. There's one that's called MHDD, which is from Hard Drive Guru, and he basically wrote a tool that will scan a drive and it will give you feedback and tell you I'm able to read a drive or I'm having an error. This is a 512 byte piece of data, and you will notice this 512 byte piece of data, I mean, it's got quite a bit in it. You'll see that the servo data is there, which is the geographic information. Then you'll see 14 bytes of null, and the 14 bytes of null are there because as the drive encodes data and puts it onto the platter, if it doesn't have a break, it can't tell where something begins and something ends. It would just always be high, because the bit that passes underneath it is going to always cause the hard drive's head to say, hey, I've got a bit, and I don't know what to do with it. So they came up with a sequence of bytes that are going to be null, just to give it